Hello, I'll be talking about basically R and polar system. Well, well, it's gonna be a little confusing actually on how we're gonna describe it because when we go unifying circle, we usually think of R as the length over here, which is polar, with cosine and sine as our components because that's how we define it. Now I'm gonna come over here. It's not a sin. All right, good. What am I trying to talk about? That's not a sin. I knew a solution. What am I trying to talk about? I refuse to say anything. Here it is. So we're going to be talking about the starting point and ending point of not ending point, just a starting point, initial frame. So you'll notice that if this position is here, which is 0, 0 on the positive, and then this way, which you can look at the velocity is red and the acceleration is green, you can see how it would transform into this format here, and then you see the negative over here and the negative over here that's highlighted. Um, but if you were to change it to over here, starting point, you would have to change the x and y. That's the shift of 90 degrees. Now, what did that sound like to you? If you said trig, you would be correct because that should remind you of if you're this transformations with 0, 0. Well, um, this transformation, the polar format. Funny thing enough, how about if this was an ellipse? I did not write about ellipse because it's a pain in the ass to talk about. But technically speaking, you can split into components to cosine and y. Why wouldn't that be helpful? The answer is there's many reasons, but there's also, if you look at the book, many books, there's I believe Kepler's law. Kepler's law. If you look at any physics book, there should be Kepler's law. I didn't make any questions on it yet because I still don't really fully understand it, and I'm still trying to get it really. And my lesson on Kepler's law was like 5 seconds long. It was really no, it was not on the test. It was never on anywhere. So I really don't know what the shit they're talking about. Oh, the only thing I know is that it's t squared divided by r squared r cubed. But what I do know is that if r is equal to, let's just say, let's look at this question over here. R is equal to 16 divided by 5 and 1 minus 3 divided by 5 cosine angle. If I multiply that by cosine, you get the x component because this equals to r, and we know if you turn to polar, it is x equal to r cosine angle, which means r is this, right? So we can plug that r into here and multiply by cosine theta to get x, and same instance for y. We've been doing that over here. It's just that we never really cared too much because, yeah. And then this over here is getting to rectangle form, actually, when we do a vector of a polar. So now you get what we did, hopefully. Um, Now we can talk about how gravity is actually what's the word again? Conservative if you want. So conservative force is basically if you have Fx and then if you have if you have Fy, it works, and then if you do integral of Fy divided by x, it dx, it should ultimately give you zero, give you the same number, which usually is 0, 0. But yeah. Now we know that the force equals to m G with a minus J, so it's a negative F equal negative mgj. But reality, 9.8 is always negative, so you can do positive if you want. It really doesn't matter. You just, and the potential energy for is U equal mgy. So what does that mean? It means that it's conservative because two reasons. You can get the derivative of this to get 0 and mg, or because that's the one way of it, getting a potential function by doing an integral of mg. Um, sorry, that's wrong. Oh, that's not what happened. You could take mg and take a derivative of dx, then the dy, and you would get 0. And in reality, you would have already gotten 0, and you're getting 0 again. So actually, this would be 0 divided by dx, which is even more confusing, which is why I don't like it. Another thing to consider is if you're doing the big expression with g big mn divided by r squared, you can obviously see that that's x over there, which means x, and again the derivative, that's 0 and then 0 again, so it's just 0, which is why it's worthless. Right? That is conservative. What other topics is going to be fun? Well, we do need to actually finally discuss about these crazy radiant and detectress things. Um, Honestly, I think I explained it really well with the pictures I showed you over here. It should be pretty well explained here. Um, do you want to talk about more physics then? Well, I'm just talking to myself at this point, but there's some physics problem if you want. I don't know. Maybe I should make more chemistry questions. It's pretty lacking there, isn't it? I've stopped doing chemistry after I've done with the class because it was a torture for me. But now I'm thinking about it. I probably need to do valence electrons and other stuff that probably is important to people to learn. Yeah. Okay, I'll do that soon. So, that's interesting, but I don't want to talk about that. I have a lot of things to unpack and make it into questions and make it into biteable chunks. Usually, I make questions first, then make it into bite chunks, but I think I need to do the opposite way around. But we'll see later. I think let's stop the video